So to recap the last couple slides, we saw that actually this graph with repeated outputs was a function um, that each input is paired with exactly one output. It's okay if the output is reused. Um, and so a horizontal line is a function, but a vertical line is not a function. I guess in some ways that does tie into the fact that a horizontal line had a slope of zero, which was more understandable. This obviously is not the reason why these aren't functions, but a horizontal line had a slope of zero and a vertical line had an undefined slope. Um, and then you kind of thought about, well, then are what type of line isn't a function, or when is a line a function or not a function? And a good um, sort of example of a function would be a horizontal line like the last one, where we can reuse outputs. And then one that is not a function is the vertical line, where one is paired with five and one is paired with -5. That breaks the rules of a function. Each input, one, should be paired with only one output, not two different outputs. We can reuse outputs, but we can't have one input go to two different ones. Think of the, apologize, I'm going to flip back. Think of the fork in the road like this. If we see a fork, or we can picture a fork where an input is forked to different outputs, we know that it is not a function. And this is not the fork, right? There's only one line drawn from 0 to 45. So this is a function. And then the easy way to kind of summarize this is the vertical line test, which is that if we imagine a pencil or ruler scanning across, and we get to a spot where the vertical line hits the graph at more than one spot, then we can determine that this relationship is not a function. So right now it's not hitting it. There's a moment where it hits it once, but the fact that it does hit it more than once at certain spots would tell us that actually this classic Euclidean shape, geometric shape, mathematical shape of a circle is not a function. And so this is an easy way to kind of test graphs. And we can still use this also to just think about the definition of a function. That when the line hits here, let's say at 1 for x, 1 is paired with two different output values, which breaks the definition of a function, which is that each input is paired with exactly one output.